Greetings and welcome, friends. Mr. Waddy here. We are continuing our lesson. I guess this is part 2 of graphing f of x equals ax squared plus bx plus c. We're going to start with another example, kind of like the ones we've already done, but I just want to make sure we're super sharp on these. So let's first label for problem. This is monitoring progress number 6. Let's figure out what A, B, and C are going to be for us. So Brandon, what are your thoughts? Perfect. And if you're on a test and you can at least tell me this, give it to me, because then I can at least throw you a point, even if for some reason you didn't know how to do the rest. So let's, if I'm going to graph this, oh, I forgot to describe the domain and range of the other one. I'm going to find h by doing the negative b over 2a thing. Let's see, so that's the opposite of negative 10. Divided by 2 times negative 5, yep. And so let's see, that's going to be positive 10 over negative 10. Nope. Nope. Negative 1 is the value of h. And now to find k, well, let's see. This one actually takes some calculation. Actually, instead of f of h, I should call that p of h. Because they happen to name their function p. And I'm plugging in this value here. Yep. So let's see. So p of h is going to equal negative 5 times negative 1 squared minus 10 times negative 1 minus 2. And let's be careful with our PEMDAS in here. So negative 5 times negative 1 all squared is positive 1. Negative 10 times negative 1 is plus 10. And then minus 2. Let's see. Negative 5 times 1 is negative 5. Plus 10 minus 2. Negative 5 plus 10 is... Yep. Yeah, so k is going to equal 3, and therefore our vertex, is the point negative 1, positive 3. There we go, yeah, oops. So let's plot that over here, negative 1 and up 3, making sure I'm paying attention to my scales. In this case, each grid mark represents 1, so we're good there. Axis of symmetry, x equals what number? Negative 1, right? It's just the x-coordinate of the vertex. So I can draw my line of which the mirrors happen. Yep. Unfortunately, I gave you a grid where this already fits. Question, which way do you think this parabola opens based on the A, B, and C? How do you know that? It opens down because the A is negative, so it's going to be downward opening. Let's see. Anyone know what the y-intercept is? How'd you get that? Yeah, it's just whatever C is, right? The y-intercept is just negative 2. So here's negative 2 on the y-axis. Does anyone know a good alternative point I could find? Let's see, Tyler, once I find this y-intercept, what's a way I could get a freebie other point? Do you know? Tyler? Or describe to me what you would do. You don't have to necessarily know the point itself. Yeah, so it's a 1 unit away from here, therefore, yeah, 2 units all the way over, or 1 unit away from both sides of the axis of symmetry is going to give me the parabs. And then we could, ugh, man, that was terrible. Something, you know what I'm saying. That's why having like the fourth and fifth point is a good idea when you can get it. Let's see. They wanted the domain and range. So the domain is everything, the set of all x such that x can just be anything. But what about the range? What are the possible y values? The y values that work for this are everything beneath it, right? And the highest point is what number? Yeah, 3 is the highest point that it gets to. So the range is everything less than 3. So the set of all y such that y is less than or equal to 3 would be the range there. All right, so that's all stuff that you can find out from this graph, like so. So that's just kind of like a quick little review from yesterday's. Let's talk about this idea of maximum and minimum values. Maximum and minimum values. Here we go. So the y-coordinate of the vertex of the graph is the maximum value of the function whenever a is less than 0. Okay, so it's opening down, right? If it's an opening down parabola, the maximum, it's going to be a maximum because it'll be the top of the parabola. And it is the minimum value when the function is opening up because a is greater than 0, right? So this would be the bottom of the graph. So these are referred to as maximum and minimum values. Later on in Algebra 2, pre-calculus, both of those, you'll actually get crazy graphs like this. And you can have, no, it is actually a function. And you can have local maximums and local minimums, like kind of mountaintops and valley lows. And they're not necessarily the highest point for the whole graph or the lowest point for the whole graph, but locally it's the top of a mountain, you know, or it's the bottom of a valley. So you can have these ideas there. But right now, today, we're just thinking about maximum and minimum, and these happen to be the max and min for the entire graph. So let's see. Let's look at example 3 together. Let's do it. Here we go. Actually, or could someone answer the question for me? What is it? Does this graph that we just did have a maximum or minimum? It has a maximum, and what was the maximum value we hit? 3. 3 was the highest that this ever got, all right? There you go. Let's do this one together. We did that other problem, so we might as well have gotten the benefit of it, you know? Yeah, so let's label A, B, and C. Notice, based on the directions, we don't even have to graph this. Okay, I agree. Now, where does the maximum occur? Or is this a minimum? I don't know. Right, so because this is opening down, we'll write that down in a minute. Let's see. It's going to be the y-coordinate of the vertex, right? So I'm going to want to figure out where's my vertex, and we can do that without graphing it, right? So let's see. I like the idea. Let's write down the fact that it opens down. So we're expecting this to have a maximum value, right? It's going to be the top of a hill rather than the bottom of a valley. And I can find the vertex using my little formula, negative b over 2a, right? So let's do that. So h equals the opposite of negative 24 over 2 times negative 4. And so finding the maximum of a parabola, right, I could end up using this to answer the question of, right, when I throw a baseball in the air, what was the highest it went? Right? I could actually measure that using parabolic motion. So let's see. The opposite of negative 24 is positive 24. 2 times negative 4 is negative 8. And that's going to be negative 3 is the value of h. So that's the x-coordinate of the vertex. And k is going to be whatever I get when I plug that h into the function, right? So that's what I'm So I'll do f of negative 3 is going to equal like negative 4 times negative 3 all squared minus 24 times negative 3 minus 19. Right. So, let's simplify this. Negative 4 times negative 3 all squared is positive 9. Negative 24 times negative 3 is going to be positive. Let's see. If it was 25, it would have been 75, right? It's 25 times 3 is 75. So 3 less 72, right? Yeah. Minus 19. Negative 4 times 9 is negative 36. Plus 72 minus 19. And these two combine. I don't know if you guys have noticed this pattern yet, but a lot of times parabolas happen to have this number often ends up being half of that number when we're finding the vertex. Did you guys ever notice that? Right? This number is half of that number. And 72 minus 36 is going to be positive 36. So that's a good little trick right there for you. 36 minus 19, 36 minus 20 would have been 16. Plus 1, 17. Is that right? Yeah. And so that means k is equal to 17. And so we were expecting this to have a maximum value, and it occurs at the y-coordinate of the vertex, which is 17. Right? Not bad at all, not bad. So, let's apply this to example 4. Sorry, what was your question? Negative 317 is the vertex. They just wanted the maximum. So I just said 17. But you're right, that is where the vertex would be. Right, so you can now answer some interesting questions like that. Ooh, look at this. Example 4. The suspension cables between two towers of the Mackinac Bridge in Michigan form a parabola that can be modeled by blah. Wow. That is a crazy A value there. Wow. All right, where x and y are measured in feet. What is the height of the cable above the water at its lowest point? So I'm looking for how tall is this? What is that distance? Well, no. No, the height? The height? The height. So 500 is there, so this would be 250. So it's less than 250, but we could figure this out. Let's label our A, B, and C. So A is going to be what? 0.000098. Is that positive or negative? And it is barely positive, right? It's getting pretty close to 0 at that point, but it's positive. B is going to equal negative 0.37. And C is going to equal 552, not 72. There we go. All right, that's since we already have a graph here, yeah, you can read that off the graph pretty well. So let's figure out what h is. Right? H is going to equal negative b over 2a, and that's going to be a crazy small number for the 2a, but that's fine with us. So the opposite of negative 0.37, this is going to be a calculator problem, by the way, over 2 times 0.000098. So that's going to be positive 0.37 divided by 2 times. I think that's going to end up being 0.000196. So only 3 zeros after the decimal. And I'll do 0.37 divided by 0.1230196. And I get h equals 1887.76 feet. What does h represent on this graph? Or where is h? How would I have spotted h here? Right, but graphically, what does h represent? No? That h normally would have represented that. H is the x-coordinate of our vertex. So that means this 18,000, it means I picked the wrong point. 18,000 is more like right here. Right? Yeah, so that means I couldn't spot it on the graph that well. So here's, right, roughly 18,087 feet over from this pylon here is going to be where the x-coordinate of that vertex is. And now I've got to find the y-coordinate, which will be the height above the water. So, and that is feet. Yeah, they were measuring in feet, they told us, I believe. Yeah, measured in feet. So let's see. So K is going to equal whatever f of h is. And I don't even know if... Let's see. I'm going to have f of h. I'm going to need a lot of space for this. I'll scroll down again in a second. I'm just writing the equation. 0.000098 times h was 1887.76 squared. All right. Oh dear, I lost it. Minus 0.37, minus 0.37 times, once again, that h number, 1887.76, and then plus 552. Okay? All right. Wow. This is a crazy thing to have to PEMDAS here. So I'm going to do this 1887 number and square it. So I get 0.000098 multiplied by 3563619.32. I'll call it 33. Minus, and then I'm going to have to multiply that by that number. So 0.37 multiplied by 1887.76. Come on, you'd be great at it. 698.47. We'll call that plus 552. All right, so I've got to multiply these things now, right? Oh, I should have done that all first. 0.00098 multiplied by 3563619.33. And I get 349.23 minus 698.47 plus 552. I'm going to do this number minus 698.47. Yeah. And then add 552. Whew. Lots of calculating here, and I get this, 202.76 for the value of K. And that's measured in feet. Yep. So I'm just gonna leave that there for a minute. Right, so we are able to calculate that exact height once I knew the equation of the parabola, and I could figure that out. Right, and we were also able to find this additional piece of information, which, I don't know if you guys realized, was what is halfway between these two towers that the bridge is supported by, is what we're able to do there. Right? Because parabolas are symmetric, right? They have the axis of symmetry, so they're mirrors of one another. Which, another interesting thing about parabolic motion, if I'm thinking about projectiles, is that the path that it follows on this side is the mirror image of the path on that side. And that also works for by shooting a basketball or whatever it might be. That it's the time it takes to travel up to the top is the same as the time it takes to travel from the top down, is the idea. All right, I think that's all I'll get to for today because I want you guys to be able to practice some. So have a great day. Bye-bye.